Alrighty guys, so we're going to discuss the answers for 1D kinematics free fall problems that you did in the collaboration space. So please keep in mind that there are certain things we need to know before we solve a problem in free fall motion. So first thing is we always take up as positive for all the problems. We take up as positive, that means down is negative, okay? We take ground level or bottom level as zero position. Let's assume you're going to throw an object up. So after you throw it, it's going to move up, right? Initial y position, y naught, is going to be 0 because that's the bottom level. And let's assume you are going to start from a certain height above the ground, and then let's assume you're going to drop it. Okay. So in that case, your initial position, we don't know yet, but final y position is going to be 0 because it's reached the bottom level starting from a higher level. So we always take the ground or bottom level as the 0 position. It depends on the question how it is worded. Let's assume you're going to throw an object up, so initial y position is 0. Let's assume you're going to drop an object down. Final y position is going to be 0 and in that case. And velocity at maximum height is 0. The object is going to come to a rest at the maximum height, and then it's going to turn back and reach the ground. And when you throw an object up, initial velocity is not 0. You cannot throw an object up with a 0 velocity. Take a object, take a pen or take a bowling ball, take any object you want and try to throw it up. Can you throw it up without giving it a force? You can't, right? You have to move your hand to throw it up. So that means you're giving it an initial velocity. When you throw an object up, its initial velocity is not 0. But let's assume you're going to drop an object down. Take an object and just drop it. You can see it doesn't really matter. You don't have to give it an initial velocity. It's going to reach the ground because acceleration due to gravity is downwards. Earth is pulling objects toward its center. So when you drop an object, initial velocity is 0. You don't have to give it an initial velocity. If an object is in free fall, only force acting on it is force of gravity. That's why we say the object is in free fall. We assume that there is no air resistance, and acceleration of an object in free fall is negative 9.8, meaning it's downwards. Acceleration is downwards. Okay, it's negative 9.8 meters per second squared. When an object is going up, it's slowing down, and when it is going down, it's speeding up. Let's draw a motion diagram for an object that is thrown upwards. You will see the spacing between the dots is going to decrease, and when it comes back, the spacing between the dots is going to increase. When it is going up, it is slowing down. Why? Because velocity Vy is up, but acceleration Ay is down. When velocity and acceleration are in opposite directions, the object is going to slow down. But when the object is coming back, it's going to speed up. Why? Because acceleration is downwards. It's always downwards. Now you can see velocity is also downwards. So acceleration and velocity both are in the same direction. The object is going to speed up. Okay. Slow down and then speed up. So very important, and when the object is at the maximum height level above the ground, its velocity is 0. that point when the object is at the highest point in its trajectory, it comes to a stop. Okay, so that's another thing you need to know, which I covered under the hints. Alrighty, so with this in mind, these hints are very important, guys. Let's go to the kinematic equations. So these equations you have already used these equations, but in x direction. Now the only thing I have done is I have replaced x using a y. Okay, so Vy is the final velocity, V naught y is the initial velocity, y is the before that, let me write down ay. Ay is the acceleration. We already know it's negative 9.8 meters per second squared for free fall motion. T is the time, very easy. And then we have y and y naught. Y is the final y position, in y direction. Y is the vertical plane, guys. And then y naught is the initial y position. Initial position in y direction. Okay. So the remaining variables, the Vy, third equation, it's the same thing. Final y position, final y velocity, square it. It's equal to initial y velocity squared plus 2 times acceleration negative 9.8 times final y position minus initial y position. And last equation is for the average velocity. It's equal to displacement. This is the displacement in y direction. Displacement in y direction, delta y divided by the time interval is equal to initial y velocity plus final y velocity divided by 2. Okay, alrighty, so let's go to the next page and see the questions. Alright, so first question is, it says a ball is dropped off a cliff. It is traveling 20 meters per second just before it hits the ground. How long, that means time, did it take for the ball to reach the ground? So when you do this question, guys, you have to first draw a diagram. You need to visualize it. So you take an object and you drop it. Okay, so we know that when I say you're going to drop it, that means it has a initial velocity of 0. Let's assume you are on a top of a building and you stay here and you drop the object. It's going to start from here and it's going to speed up. Okay, and V naught y is equal to 0 because you dropped the object. Okay, and then final velocity, it's traveling at 20 meters per second just before it hit the ground. So before I do anything, I'm going to write down my up is positive. So when it is going down, this final velocity Vy is going to be equal to negative 20 meters per second. And then acceleration in y direction is always negative 9.8 meters per second squared. So now we have the initial y velocity, final y velocity, acceleration, and that's all we know. We're asked to calculate the time, t. Okay, so that's an unknown. Now I need to choose the correct equation. So let me use the first equation out of the 4 equations we have. Let's assume I have no idea whether it's going to work or not. I'm just going to write down it and I'm going to see whether it's going to work for me or not. Now, let me put a tick mark for the ones that I know. Do I know the final y velocity? Yes, it's negative 20. Do I know the initial y velocity? Yes, I dropped the object, so it's equal to 0. Do I know the acceleration? Yes, I know it's negative 9.8. Do I know the time? No. So when you choose an equation, guys, you need to choose the equation that has just one unknown in it. Because this is like an algebraic equation. When you choose an equation, you need to make sure if you have one equation, you just need to make sure there's only one unknown. Okay, so what I'm going to do is I'm going to substitute for Vy negative 20 meters per second is equal to initial is 0 because again I dropped the object, negative 9.8 meters per second squared times the time t, and I need to make sure I separate t on one side, which means I have to divide both sides by negative 9.8 meters per second squared. Divide both sides by that number and you get an answer for t. So my t is equal to 20 divided by 9.8. You can do it on your own first. You can pause the video and do it. Should get 2.04 seconds. Okay, the unit is important. It is seconds. Alright, 2.04 seconds. If it is not clear, let me write it down again. So that's the answer for first question.